Hi, everybody, and thank you for being here today. I'm Marcella Faraone from FS Technology Italy Rome, and today I'll talk about our contribution to a project that regards the implementation of advanced workflow in Construction Cloud for the construction site management. This class is a follow-up of the class presented last year about the virtual construction site management with advanced workflow in BIM 360. I will describe the improvements made this year through the adoption of the Build module, including the Plangrid Build mobile app for field workers. We have been widely extended the use of Construction Cloud with the digitalization of other construction processes in addition of those already implemented. Moreover, with the use of Forge and Construction Cloud Connect, we are developing integration with other company database and legacy IT systems to avoid data redundancies and to build up integrated dashboards. We are focusing our attention on setting up workflows for safety, environmental, work in progress, and quality checks in the work site. And now, just a brief introduction of our company and our team. FS Technology is the high-tech company of the Ferrovie dello Stato Italiane Group. It has been created at the beginning of 2019, and its mission is to strengthen and support digital innovation in the group companies. I'm the head of Competence Center BIM-GIS, that is a team inside FS Technology. Together with my team, at the end of 2017, I started the successful project of integration between BIM and GIS. For this work, we received the Special Achievement in GIS Award in 2019 by ESRI. During the last 2 years, I focused my attention mainly on construction phase, setting up workflows for inspection surveys, safety, and environmental check in the work site. I have a BIM management experience acquiring the Red Line North Underground project in Doha, where I worked from 2014 as MEP BIM coordinator and as a BIM manager for the Italfer team. So, our work consists in the analysis of the current processes and workflows and in the improvement of these processes also with the introduction of new technologies. We mainly support Italfer, which is the engineering company of the group, during the design and the construction phases, from the preliminary design to handover, and Rete Ferroviaria Italiana, which is the company of the group owner of the entire railway infrastructure for the asset management. For this project, we've been collaborating with Autodesk, and I want to thank especially Simone Capocchien for his support with ESRI, and engineering. In particular, I want to thank Raffaele Ausiello and Mauro Balcerini for their contribution for the development of connections with other tools and database with the use of Forge. In the following, just a brief recap of where we were in 2020. In July 1996, the European Commission adopted a resolution to implement the Trans-European Transport Network, TNT. The intent of this multi-phase project is to provide coordinated improvements to primary roads, railways, inland waterways, airports, seaports, inland ports and traffic management systems throughout Europe. When complete, the Scandinavian Mediterranean corridor of the TNT project will stretch from Helsinki, Finland to Valletta, Malta. The Napoli-Bari high-speed railway project is a part of this corridor and was initiated in 2015. We've been focusing our activity mainly on these projects. With BIM 360 document management field, we implemented quality checks and inspection surveys. We are talking about of all those controls that the construction management must do on site to check the works are built on site according to executive design. Starting from the standard procedure, we developed a series of checklists. The control activities were divided for heavy work into different phases: preliminary activities, construction phase, after construction, and final check documentation. Every item with a close answer. In the following video, the construction site manager will describe the project and improvement made with the use of this technology.
Hi, we are engineer Marco Russo and Daniele Borrelli, site inspector. We are part of supervision work team for the realization of railway doubling of the itinerary high-speed, high-capacity Naples-Bari.
Our role is to verify the works are executed in coherence and respects for the projectual instruction and obligation imposed by current regulation.
The route Naples-Bari is part of the initiative for the development of a sustainable mobility, promoted by the European Union to achieve the European Corridor System, Trans-European Transport Network, Scandinavia-Mediterranean. The new line is going to extend for about 150 kilometers of route and to allow reduction of journey times, so you can travel in 2 hours non-stop from Naples to Bari.
Napoli-Bari project is divided along its length in several sections. Napoli Cancello and Cancello Frasso Telesino in progress. Frasso Telesino Telese, San Lorenzo Vitulano, Apice Irpinia, Irpinia Orsara, and at the end Orsara Bovino. As regards Cancello Frasso Telesino site, where we are carrying out our direction of works, it extends for about 17 km of double track line and crosses 5 towns situated on the border between Caserta and Benevento districts. Among the most important works to realize there are Monteaglio tunnel of about 4,200 meters, 8 viaducts that cover about 3,700 meters total of line, and about 9,000 meters of mixed railway headquarters that includes embankments and trenches.
There are multiple and articulated checks to make inside, and for this reason Italfer has chosen a pilot testing process, including ours to optimize and digitize standard controls to make in the context of direction of works activity. By the use of an ITM platform available on tablet, smartphone and PC, it is possible to write both inspection report and standard control plan by the technical tender dossier.
Among the advantages of the digitized management of the checks inside the building site, you can highlight a time reduction of reports compilation of daily inspections, drawings online on a cloud, therefore the possibility to have anytime a contract document or project paper, a digital memory. The previous control lists are online and this allows to compare preceding results with the current situation.
Despite of the good feedbacks from the field, there are some lack of capabilities in the use of BIM 360 Build that convinced us for the adoption of Autodesk Build during this year. Analyzing the outcome expected from Autodesk construction managers, we listed the lack of capabilities in Autodesk BIM 360 to understand in which way we could fix the issues. For example, major issue was the difficult to synchronize the checklist in absence of weak internet signal, with the consequent loss of data. Some limits in adding different sections inside the checklist, like workers, vehicles, or weather. Or lack of information about the activities made from the user on the checklist, or the availability of some kind of report or format. Starting from this analysis, we decide for the adoption of Autodesk Build. In order to avoid the loss of data in the passage to BIM 360 Build to Autodesk Build, we had to do some technical steps. First of all, change permissions on BIM 360 and made all projects read-only to avoid creation of new checklists in the old environment. Second step, with the use of Insight, we downloaded the old checklists from BIM 360 and uploaded them inside the proper folder structure in Build. All of these checklists has been saved in PDF format. The use of Insight allows us to maintain inside the PDF the links to the checklists in BIM 360. I want to highlight only one point that can create some difficulty in this passage. In BIM 360 Build, we have the possibility to automatically create the project and its folder structure with the use of Forge APIs, starting from an Excel file. At the moment, in Build, we have to create manually the folder structure, usually using a desktop connector, because the same APIs are still not available. Anyway, in one of the latest releases of Autodesk Build, the functionality of import of checklist template has been released. Obviously, this functionality will help us to avoid the work in creating checklist templates again. Another useful functionality recently released in Autodesk Build is the possibility to import location using the same Excel file used to create a location in BIM 360. Moreover, in this case, we also have the possibility to update these locations due to the fact that an ID is assigned to a single WBS. So, respect to the outcome expected from it of construction managers, what are the improvements made with the use of the Autodesk Build? Referring to the previous list of the lack of capabilities BIM 360 Build, we can see in the slide all the fixed issues. Now, let's see just some examples of these improvements. Data loss during weak or absence of internet signal. With the use of new app, we can download data and use the app offline, for example inside a tunnel. The data are stored till the app is again online. Allow the workers in field to upload the saved data. Another important improvement. Now we have the list of all activities made by the user on the checklist. We have the possibility to visualize the photo not only inside the checklist, but also in a section that allows us to share them, make report and visualize a map with the photo georeferenced. It's very simple now for the field workers to insert sections like weather, workers, and vehicles. Weather can be inserted directly on the checklist and not only on the project. We have the possibility to duplicate a checklist already filled in and upload many photos at once. And these are the remaining expected capabilities we hope to have soon available in Autodesk Build. The possibility to edit the photo in the app, the export in PDF format of the checklist with only the section filled in, and the possibility to insert a large number of characters inside the open answer. First, feedback from the field. The new app has been very appreciated and has been seen as an improvement of the previous app and not as a new app and a new way to work. Very much appreciated are the resolution of synchronization issues and the fact that we have no more differences between the iOS and the Android app. The video functionality to record as is status of the construction site, the upload standard checklist to the PDF file, and integration of the app with other instruments like WinZip and sending PDF. As already mentioned above, at the moment we are waiting for the release of a series of Forge APIs to connect other company databases and legacy IT systems to avoid data redundancies and to build up integrated dashboards. Now I just want to show you two examples of what we are going to develop through Construction Cloud Connect and Forge. Creation of a new project filled in with data from another application called Construction Online, and definition of users and rules from the same applications. During this year, we started to develop a new workflow included Autodesk Build and the ESRI platform as a part of a project we call the Virtual Construction Site Supervision. As we understood, we can use GeoBeam in the future to optimize the workflow we are setting up. The aim of the Virtual Construction Site Supervision project is to support the activity of ITAFER in construction site with innovative workflow and technologies. The main objectives are environmental check during construction, construction safety check, and quality check of the works. To do this, we are processing surveys made with drones and total stations, point clouds, orthophoto, photogrammetry, thermic camera, and setting up a workflow with Autodesk Build and the ESRI platform. This project started with a proof of concept at the end of 2019 and is now work in progress. It's an experimental project and final result will be available in 2022 at the end of May. This is the current workflow. We start from the project creation in Autodesk Build, with automatic creation of the project with the use of Forge and Construction Cloud Connect, the update of all information regarding the project from other systems, automatic authorization of the user on the document management, and upload of all project data, models, drawings, etc. Following is a project publication in the ESRI platform and the creation of GIS web app through ArcGIS Pro. And then the plan of the surveys through the use of project management and the creation of RFIs to identify the areas and the part of the works to be surveyed, both in GIS web app and project management. So, we start with standard folder structure. This is an example of an existing project and this folder structure. Instead, for the drone survey project, we have to still define the standard structure. After this definition, we will add this part of the structure to the main structure of the project. At the moment, projects such as drawings and Revit files are still not codified, and no metadata are associated to this file. This is just an example of a viaduct model inside this structure. Inside the document management, we use different folders where we upload the drawings to identify the areas to be surveyed, to create the request for information. Inside the RFI, we have as a data the link to the GIS platform. With the RFI, we can follow the survey activity. We need to define the standard and the best folder structure and the right metadata that we need associated to the file to be compliant in the next future with GeoBeam. And now, how to set up and to publish the project inside the ESRI platform. To publish the project data, such as Revit models, Civil 3D models, and drawings in ArcGIS Pro CN, we used the Connection Cloud functionality following the steps. First, creation of a local scene in ArcGIS Pro, then the connection to Autodesk Construction Cloud with the tool New Cloud Big Connection, and then to connect the RFI created inside the project management. Currently, we have to add the link of the RFI directly inside the local scene database as a metadata. This is an example of the published local scene completed with all project data, the track, the works, construction site areas, and viaduct models. The areas to be surveyed are identified through the layer inside the local scene and connected with the RFIs created inside the project management. With GeoBeam, we expected that once the areas are identified inside the local scene, we will be able to create the RFIs directly in this local scene. And this is a video made during one of the survey sessions, just to complete the information overview of the project. The survey session has been made on the Cancello Frasso Telesino construction site inside the Napoli-Bari. The user field and the user from a remote site need to have visualization of the results for further analysis. And this is what we do to help them with the instrument available at the moment. PowerBI dashboard, point cloud publication with Pebble View, and publication on GIS local scene, and site analysis with HoloLens, remote final testing of the works for handover, remote analysis of the surveys. We need to publish Bubble View point clouds inside Build for remote analysis of the works. Also, if we are experiment a lot of technical issues during the publication made with Recap Pro. And this is the description of the current procedure to publish point cloud layers. The head of the last file to the local scene, the user tool define projection, the user tile last and create dataset last to transform the last in dataset creation in last files, the user to create package layer, upload the SLPK package inside the Enterprise portal, and upload and create layer inside the web scene. As you can see, this procedure is a little bit complex and takes many hours. We expect to simplify this procedure with GeoBeam. And this is an example of the resulting web scene with all project data, the track, the works, construction site areas, and viaduct models overlapped with the resulting surveys taken at different time. As you can see, we can check the work in progress turn on off the point cloud layers at a different time and compare the difference also with the models. At the moment, we are collaborating with Autodesk to optimize the workflow and to be ready when GeoBeam will be available. Expectations is to manage and improve the construction process of linear infrastructure project in order to improve data quality, reduce costs and times by 60%, reduce wastefulness, and promote sustainability in the upcoming years. Thank you very much for your attention.